My name is Abram, and today we're doing mathematics with Natasha. It's been a while, Natasha. How are you?
It absolutely has, Abram. It's been way too long. I'm very well, and hopefully all of you mindset is at home. It's not too late in the afternoon on a Friday for maths. It's never too late for maths.
We really missed you, hey?
I missed everyone too. It's great to be back. And hopefully things just carry on from here, and the mindsetters are ready to learn. They've had a big break from the live shows, and so I'm sure they're ready for it now.
But Easter School, I must say, since it has started, mindsetters have been learning more, and we continue to teach them. Guys, make sure that you get your notes. They're all for free from land.mindset.co.za. Otherwise, I've already posted them for you guys on our Facebook page, which is facebook.com/learnextra. We've got exciting things happening on the show, competitions that are coming. I'll tell you more about the workbook that we're having, of which the notes that you're going to be using, downloading, and Natasha is going to be using, are extracted from this very same workbook. So if you're interested in getting our workbook, let us know, guys. And yeah, Natasha, let's do this.
Okay, guys, so today on the show we are looking at trigonometry, compound and double angles, and that is obviously what you do in grade 12. It's a new section in trigonometry. You have not come across this as yet. So it's compound and double angles, and as AB said, the notes are available for you guys, so hopefully you all have it. In this lesson specifically, we're going to look at reduction of compound and double angles. So we're going to use the expansions that we learn for our compound and double angles. We're also going to look at an identity and a general solution question. So we'll be giving you a little bit of revision on all these sections you should have covered by now at school in trigonometry. Okay, I also have the challenge question for you guys for today. So I hope that you all get the answer to this, because you've been working really hard in the first term, of course. So we've got, if sine of 18 degrees is equal to t, determine the following in terms of t. Now, before you look at what you have to determine, what I'm going to suggest to you here is, when they've given you the information, sine of 18 is equal to t, remember you can rewrite t as a fraction as t over 1. Okay, so let's see if that can assist you with this question. Some of you might know exactly what I'm talking about what you need to do. So you can rewrite t as t over 1. All right. You then need to find cos of 18 degrees and then sine of 78 degrees. So guys, give that a crack. Let's see if you guys can get the answers. I'm sure lots of you will be able to by this stage of trigonometry. And then I just want to go through a brief revision of what you would have done up until this stage. Now, remember, like every other section in maths, it's building blocks. All the work that you've done in trig in grade 11, you need to know all of that, because it will be examined again at the end of grade 12. But very importantly, the new identities and expansions that you learn in grade 12 are the ones that I've got on the screen here. We'll go through each of them. Those very important for grade 12. So if we look at our compound angle identities, you've got sine of a plus b is equal to sine a cos b plus cos a sine b. What you will notice here is sine of your compound angle a plus b. When you do your expansion, the sign in the middle of the two terms stays exactly the same. So sine a plus b, you have your sine a cos b plus cos a sine b. Similarly, with sine a minus b, you've got sine a cos b minus, stays the same, cos a sine b. But now if you have a look at your cos expansions of your compound angles, cos of a plus b becomes cos a cos b minus sine a sine b. So what you can see clearly there is, in your compound expansion for cos, your sign in the middle will change. All right, so we're going from cos a plus b, and then the sign between the two terms is going to take on a minus. Okay, there is theory behind this, but all you guys need to know is how to apply these expansions. Okay, cos of a minus b, similarly, we've got a minus there, so we see that the sign between the two terms when we do the expansion has changed to a plus. We've got cos a cos b plus sine a times sine b. Okay, double angle identities. Now, you've got sine of 2 theta being very easy to remember, although you don't really need to remember these, but sine of 2 theta is equal to 2 sine theta times cos theta. So why don't you need to remember them? Because they will be given to you, all right? But I find that if you're doing enough practice, you remember them offhand anyway. So sine of 2 times an angle is 2 sine theta times cos theta. That is the only option when you're trying to expand sine of 2 theta. But if we now look at cos of 2 theta, and I just want to make a note here for any of you who are looking at the first line, that shouldn't say cos squared theta there, it should be cos 2 theta. Okay, but it's in the expansions that I'm going to look at now. Cos of 2 theta, there are 3 different ways to expand and arrive at the same answers. So cos of 2 theta, we've got 3 choices. We can either use cos squared theta minus sine squared theta when we are simplifying, or we can use 2 cos squared theta minus 1, or 1 minus 2 sine squared theta. So when do you use each of these? It really just depends on the question when you're going to need to use these. Especially you guys will see when we do general solution and in identities it comes up where you've got to decide which one do I use, and the question is what needs to guide you. All right. What I'd like to do now is go over a quick 2 examples. If we've got time before our break, let's go over some examples just to remind you guys how to expand and how to use compound angles. So this is example 1, and it says grade 11 revision, but it's actually grade 12 term 1 revision because you only learn this in grade 12. So we're saying simplify cos A plus 60 plus cos A minus 60. Okay? So we've got cos A plus B plus cos A minus B. We're going to use our compound expansions for cos in order to simplify. So cos A plus 60, I can rewrite it as cos A times cos 60. All right. Plus, okay, and I was about to make a mistake there, and hopefully you all are awake, and that's what I'm hoping that you're on your feet because it is 3 o'clock on a Friday. But if we're going to have an expansion of cos A plus B, remember, go back to your expansions. If you're looking at cos A plus B, what does your expansion say? If I'm using cos A plus B, I need to change the sign between the 2 terms. So it's going to be cos A cos B minus sine A sine B. So this should be minus sine A times sine 60. All right, so that's just the expansion for the first term. All right, then we say plus, and I'm now doing the second term, we've got cos A minus 60, so using my compound expansion, I'm going to get cos A times cos 60. Look at the middle sign, it is a minus, so that means my next term should be minus sine A times sine 60. When you get to this point, you're going to add your like terms, collect your like terms. We see we've got cos A times cos 60 plus cos A times cos 60, so that will give me 2 cos A cos 60. And then we've got minus sine A 60 and minus, all right, okay, now look at what I've done. I'm very naughty. Saying to you guys, remember to change the sign. Do I change the sign? No. We've got a minus there in the middle, so that needs to become a plus sine A sine 60. So we've got minus sine A times sine 60 plus sine A sine 60. They're exactly the same with the opposite sign, so they cancel out. All right. 2 cos A times cos 60. Cos 60 is nice to work with because it is a special angle. When you're dealing with special angles, remember that sometimes the question says without a calculator, which means you can use your special angle triangles or your special angles on the arc with the circle with radius 2. All right. So 2 cos A cos 60, we can use one of those special angle diagrams, and we can say, well, cos 60 I can replace with a special angle of a half. Okay, you can also double check that on your calculator. So we just go cos 60 equals a half. Okay, so you can put it in your calculator as well. So 2 cos A times a half. This 2 is being multiplied by the a half. 2 times a half, those cancel, and I just get 1 times cos A, so my answer is just cos A. All right? Hopefully you're all with me, you're all paying attention, and you're all awake. As you can see, it is a Friday afternoon, and hence some mistakes will and do crop up. So hopefully you guys are awake and you keep me on my toes. Abby, can we carry on to the next example?
Yes, let's do that.
Okay, guys, so let's carry on to our next example, just using a bit of reduction formula here and some double angles as well, potentially. Let's have a look at this. So we've got this expression we've got to simplify without using a calculator. They say tan of negative 60 times cos negative 156 times cos 294, all divided by sine 492. Now, what I just want to remind you guys about with your negative angle, because our first term there is tan of negative 60, okay? If you have tan of any negative acute angle, okay, so where theta is less than 90 degrees, your answer will just become negative tan of that angle. All right, so tan of negative theta is the same as negative tan theta if theta is less than 90 degrees. Okay, and then if we've got cos of a negative angle or a positive angle, so cos of plus or minus theta, that will always be the same, and you can actually check this for yourself. That will always be the same as cos theta, and that's even if theta is greater than 90 degrees. So what I would like you guys to do is just check this with me, because it comes up right here. We've got cos of negative 156. The answer to that, negative 0.9135, etc. And if I do cos of positive 156, you will notice that we get exactly the same answer. And you could check this to your heart's desire. You can keep on checking to try and find the exception, but there is no exception because it is a rule. Cos of plus or minus theta is the same as cos of theta. Okay. So let's use those two ideas to help us simplify this reduction formula question. All right, so I've got tan negative 60. I've just told you that's the same as negative tan 60. Okay, so we put that down. Cos of negative 156, that's the same as cos of 156. Now let's have a look at cos of 294. This is where we've got to now start thinking about our reduction formulae, and we're also going to here use the cast diagram. Okay, 294 degrees is greater than 270, less than 360, so that's going to fall in the fourth quadrant, and we know that cos is positive there. Okay, so how do we get from 294 to an acute angle? Because remember, with reduction formula, that's all you're trying to do, is you're trying to get to an angle that's less than 90 degrees. It's got to be an acute angle. So cos of 294, we know that it's in the fourth quadrant. We know in the fourth quadrant everything is 360 minus. So you can use your calculator here just for the subtraction. I mean, we're not using the calculator to get an overall answer, but just for the subtraction, we can say, well, what do I need to add to 360 to get 294? Well, what do I need to subtract from 360 to get 294? And the answer is 66. So basically what I'm doing is I'm rewriting 294 using reduction as 360 minus 66. 360 minus 66 is the same as 294, and we see that it is in the fourth quadrant, and we'll deal with that reduction just now. Sine of 492, it's an angle that's greater than 360. Okay, so it's going to be 360 plus something. Now, when you start going around your cast diagram, remember that, and I'm going to need a little bit more space, so let me just extend this. So if we're talking about our cast diagram, we know that that's 0, we know that's 90, that's 180, that's 270, and this is also the same as 360. As soon as I start saying, so this is 360 minus, and this is 90 minus theta. When I start saying 360 plus theta, I'm literally starting to go around again. So I'm carrying on with that revolution. So if I'm saying 360 plus theta, I'm going to start going back into the first quadrant and then go around again, depending on how big and how much we've got to add to 360. All right? So I can rewrite 492 as 360 plus, now 492, let's see what we've got to add to 360 to get 492. We've got to add 132. So we've got to rewrite 492 as 360 plus 132. Okay. Now that we've written everything in a reduction format, we need to simplify a little bit further. So minus times a plus, we're going to get just a minus tan 60 there. We're not going to replace anything just yet. And at the same time, I want to reduce cos 156. I can rewrite that. 156 is going to be 180 minus, and if you want to check what, we go 180 minus 156. And we get 24. So cos of 156, I'm going to write as cos of 180 minus 24, just above it. All right, so that when I do my reduction, I've got everything on the same line. Cos of 180 minus, when you reduce, 180 minus, remember, that's in your second quadrant. And cos is negative in that quadrant. So therefore, cos of 180 minus 24 is going to become negative cos times negative cos 24 times, we've got cos 360 minus 66, that's in the fourth quadrant. Cos is positive in that quadrant, so we're going to get times positive cos 66 all over. And at the bottom, we've got sine 360 plus. Sine of 360 plus is going to give you a positive answer of just sine 132, which we can then further reduce. Okay, so I'm putting this in the denominator. Sine of 132, I can rewrite as sine 180 minus. And let's have a look what we're going to subtract. So 180 minus 132 is 48. So it's going to be sine 180 minus 48, which is the same as sine 48. Why is it the same? Sine of 180 minus is in the second quadrant. We know that sine is positive there, so this will just become, or stay as, positive sine 48. All right, so that's where we are so far. We've got negative tan 60 times negative cos 24, negative times negatives are positive, so we know we've taken care of that sign. Tan of 60, we can now do that on our calculator, or you can use your diagrams to find out what the answer is, your special angle diagrams. Tan of 60 will give me root 3, so I'm replacing tan of 60 with root 3. Cos of 24, I'm going to leave it alone for now. Cos of 66, I'm also going to leave that alone for now, and I'm going to show you in the next line why. Sine of 48, I can rewrite it as sine of 2 times 24, and the reason I want to change that is because I can already see in what I've got in the numerator, I've got a cos 24. And I know that 48 is 2 times 24, so I want to bring that 24 into the question immediately, right? So I've got root 3 cos 24 times cos 66. That 66 doesn't sit well with me because it doesn't have a 24. It's not really blending in. It's not gelling with the rest of the question. So we need to change the 66. How do we change the 66? Remember, you guys learned something called cofunctions. And if we say 90 minus 24, you can check this, 90 minus 24 will give me 66. Cos of 90 minus 24 will give me sine of 24. So cos of 66 is the same as cos 90 minus 24. And from cofunctions, we know that cos of 90 minus becomes sine of theta. All right, so cos 66 is the same as sine 24. And then in the denominator, sine of 2 times theta, using our double angle expansions, it's 2 sine 24 times cos 24. And we can see we are in a good position because cos 24, cos and 24 exactly the same. We can cancel them. Sine 24 divided by sine 24, they cancel out. So our answer is just root 3 over 2. All right. Hopefully you all got that. This was a very nice question and a common exam type question. Abi, everyone happy?
Everyone happy. Thank you, Natasha. Guys, remember your challenge question is right on the page. Look for it and give us your answers. We'll see you after this break. Welcome back, awesome mind teachers, and thank you for your questions. If you don't know our Facebook page or how to get in touch with us, simply go to facebook.com/LearnExtra or follow us on Twitter @LearnExtra. Now, Natasha, I've got some comments and questions.
Okay,
Just gonna read you.
We only want to hear the good things.
Only the good things, yeah. That's what we want. Here's a nice comment from Enoch Maluleke saying, "Hi, my name is Enoch. I'm really enjoying the show. Big ups, guys. Please read my comment." I just read it. Enoch Maluleke, thank you for watching. Other mind teachers asking, okay, there's a question from Dion. We've noted your question. Koketo Mafiri says, "I'm tuned in, guys. Welcome, Koketo. I've got a question from Tabani, an answer actually from Tabani, and a question from Jenny James Bond. We'll take your question a bit later on. Keep them coming, guys. And remember, we've got exciting things that are happening. This awesome competition for K53, we're giving away a voucher worth 150 Rand. All you need to do it is to share the picture that we have posted on our Facebook page and tag a friend whom you'd like to drive next to you. So tag that friend and share the picture, and you could win an awesome voucher for you to enter for the competition. It's simple, guys. Natasha, back to you.
Okay. All right. Great, guys. I hope you're enjoying the show, and I'm glad that you are active and you're keeping AB awake, and myself. So let's get straight into our practice questions for today. This is question 1. Again, we're going to do a little bit of compound expansions and just get you guys comfortable with that concept. So we asked to show that cos of 60 degrees plus theta minus cos 60 degrees minus theta is equal to negative root 3 sine theta. So we see a compound angle. That means we need to use our compound expansions. Okay, that's the only option really available to you here. Cos 60 degrees plus theta, this will become cos 60 times cos theta. Remember, have a look, there's a plus sign in the middle there, so I need to change to a minus. That's what my expansion does. It becomes minus sine 60 times sine theta. Okay, now we have a minus between the two terms. Be careful, because if you don't put this second little bit that you're going to do in a bracket, you may forget and you may make a mistake. So use a bracket just to show the expansion for cos 60 minus theta. With your bracket, you will then remember to times the minus through the bracket and change your signs. Cos 60 minus theta is going to become cos 60 times cos theta plus sine 60 times sine theta. Okay, remember we have that bracket there to remind us we need to change our signs when we multiply through. Okay, I'm just going to expand through with a different color. We times the minus through, so we get minus cos 60 times cos theta. Minus times a plus is going to give me minus sine 60 times sine theta. Okay, Now guys, have a look at what you've got. We've got some like terms. Remember, this is all on one line. Let me just bring it down. We've got cos 60, cos theta, minus sine 60 times sine theta. Have a look at what you've got. You've got like terms that you can add and subtract, right? So I've got cos 60 cos theta minus cos 60 times cos theta, exactly the same with the opposite sign, so those are going to cancel. And then I've got minus sine 60 sine theta minus sine 60 times sine theta. That's going to give me minus 2. I just add them together. Minus 2 sine 60 sine theta. So we're looking good so far, especially because we have this special angle there. So I know that I can rewrite sine 60, again using your diagrams, your triangles. Sine of 60 I can rewrite from that as root 3 over 2. You can also use your calculator to just double check there, times sine theta. Okay, we'll see that the 2's will cancel, so I just end up with minus root 3 sine theta, which I'm very happy with because it is exactly what they asked you to show. Okay, so we've shown that that expansion will give us minus root 3 sine theta. Okay, now in the next part, 1.2, they say, hence, evaluate cos 105 minus cos 15 degrees without using a calculator. If they say hence, there's no otherwise there. It just says hence. Hence means use what you've just shown to help you to answer this question. You've got no real other option. Hence means please use the stuff you've just done. And I'm saying please use it because if you now try and go and expand this, guys, you're going to end up with a whole long expansion all over again. You would waste time and that kind of thing. So please, 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 if you say hence, use what you've just done. I've often seen students just go and re-expand and then waste time on a question like this. So hence, we use what we've just done, right? What have we just done? We've shown that cos of 60 plus an angle minus cos 60 minus an angle will give us minus root 3 sine theta. I need to rewrite, I need to get the 60 degrees involved here. I need to rewrite 105 and 15 by using 60 degrees. So cos of 105, if I want to now try and think of how do I introduce 60, well, 105 minus 60 is 45. So I can rewrite 105 as 60 plus 45, okay, minus cos of 15, and 15 is 60 minus 45. And this looks very, very good to me because this resembles exactly what we were asked to show. We show that cos of 60 plus an angle minus cos of 60 minus that same angle will give us an answer of minus root 3 sine theta. So if I use what I've just proved there, I can say, well, this whole thing, cos 60 plus 45 minus cos 60 minus 45 should give me negative root 3 sine of theta. And in this case, theta's placeholder, theta as the placeholder was representing 45 degrees. So this will be minus root 3 sine of 45. All right. Sine of 45, 45 is a special angle. That is root 2 over 2. Okay. We multiply that and we get minus root 6 over 2. Okay. It's exactly what you should have gotten using your part, your first part. Okay, hopefully you've all got that. AB, how are we doing? Everyone following? Everyone good?
The following.
Any
No.
questions on this?
Not on this question.
Okay,
Yeah,
great.
as soon as I get them, I'll give you.
Okay, fantastic. So guys, we're going to move straight ahead into question 2, and we're going to now look at identities. We've got, if we look at 2.1, we've got cos 2x in the numerator here, which I'm happy about because a lot of the times the questions will get asked is, how do we know when to change cos 2x to one of those 3 expansions? When do we use those expansions? Well, I'm going to show you now. Okay. So with your identity, you're asked to prove that the left-hand side expression is equal to the right-hand side. Okay, so we need to show that they are equivalent. So I'm going to start working with the left-hand side. Okay, I'm just writing left-hand side so you know what I'm doing, but you don't have to do that. Tan of x, we also know that can be written as sine x over cos x. It's just something we're going to keep at the back of our mind for now. All right, but let's look at the left-hand side. I've got 1 minus cos 2x minus sine x all over sine 2x minus cos x. With the sine 2x in the denominator, we really are restricted. We only have one way that we can rewrite that from our double angle. All right? So I know what to do with that. But in the numerator, I've got cos 2x. And I've got 3 different expansions to choose from, because remember, there are 3 different ways that you can write cos 2x equivalently. And what you do is you look at what you've been asked to prove. We've been asked to prove that this whole fraction is equal to tan x, which I know is the same as sine x over cos x. And if I look at that, tan x is sine x over cos x, that means that in the numerator, I only want to be left with the sine x. So that sort of narrows it down in my mind as to what expansion we should use for cos 2x. Because I'm aiming for a sine x in the numerator, let's use the cos 2x expansion that includes a sine x. So I will write cos 2x as the sine expansion. Okay? What am I saying? We know that cos 2x could be cos squared x minus sine squared x. We know that that's also the same as 2 cos squared x minus 1. And we know that's also equivalent to 1 minus 2 sine squared x. So this is the one I'm talking about. That's the expansion I want to use for cos 2x, simply because I'm aiming for sine in the numerator. So let's get to it. I'm going to write this numerator as 1 minus, and I've used 1 minus 2 sine squared as my expansion for cos 2x. So I put that in, minus sine x, and this is now all over. Sine 2x, we know the expansion for sine 2x from our double angles is 2 sine x times cos x minus cos x. All right? In the numerator, I've got 1 minus 1. If I times the minus through, 1 minus 1 will just cancel. Minus times the minus is a plus, so I end up with 2 sine squared x minus sine x all over 2 sine x cos x minus cos x. Okay, now have a look. Can we go any further? Yes, we can. I can see that I've got a common factor of sine x in the numerator, so I pull that out by dividing through by the sine x, and I'll be left with 2 sine squared x divided by sine x is just 2 sine x minus sine x divided by sine x is 1, all over. In the denominator, I can take cos x out as a common factor, and I'm liking how this looks. So we get in the bracket 2 sine x minus 1. And that's good news because those cancel, and I get sine x over cos x, which is tan x, which is the same as what they've asked us to show. Okay, so we're happy. Identities are really nice because if you do them correctly, they work out. That's all that happens. They work out. All right. Do we have any questions on this specific question yet, AB? I'm going to keep checking with you as we go.
Not on that one. I think we have a follow-up, though. It's from someone saying, can you please explain the cosine functions if there is time? I think that's not from that one. However, okay, not on this question.
Okay.
I'll reserve the other ones for later.
AB has taken back that comment. No questions. Okay. So let's move on to 2.2 very quickly. Also an identity. Another nice one because, again, we've got cos 2a to work with because we need to now decide. What is it? What expansion do I use? There's 3 to choose from, and as I said, it's the one question that I always get from students every time we get to this section. What expansion do I use? All right. So here we've got cos 2a over 1 plus sine 2a. We've got to show that that's equal to cos a minus sine a over cos a plus sine a. Again, I'm going to work with the sign that I work with the side that I can do more things to. So here I can see that I can simplify the left-hand side a little bit more than I can the right-hand side. So that means, what do? I work with the left-hand side. Okay. Cos 2a. Now straight away I see cos a minus sine a, so my brain starts thinking, well, let's use this expansion because it's already got a cos squared minus a sine squared in it, so that's good. So I'm going to change this cos 2a to cos squared a minus sine squared a. And you saw all I did was I looked at the right hand side, and I let that guide me as to what expansion I should use. Okay, that's the only trick there. At the bottom, I've got 1 plus sine 2a. All right? So I can rewrite this as 1 plus 2 sine a times cos a. And I can see already, guys, because remember, you need to always be thinking in maths. Think ahead. I'm trying to get to cos a plus sine a. I can see that there's no cos a plus sine a in the denominator. What am I going to do here? When we start thinking about little tricks that we've learned through the years that all of us have been doing maths, and I can see that in my denominator, I'm going to need to change that 1 into something special. And that special something is this. Remember, there's lots of different ways you can write 1 in maths. You can write it as 2 divided by 2, lots of different ways. But in trigonometry, we can write 1 as sine squared a plus cos squared a, which is what I'm going to do here. I'm going to change that 1 into sine squared a plus cos squared a. And the reason I'm doing that is because I looked at what they were asking me to prove, and I already saw that I'm going to need that. Okay, now let's factorize. Numerator cos squared a minus sine squared a, that's a difference of squares. So I factorize that into cos a minus sine a times cos a plus sine a. All right, and that's my numerator sorted. I can't really go any further with that. And then in the denominator, we're going to try and factorize this. We've got sine squared a plus 2 sine a cos a plus cos squared a. That was an aside, so let's just put that there. All right. I can factorize that into a trinomial. It's going to be sine a plus cos a times sine a plus cos a. All right, and you can check that. If you multiply it out, you end up with 1 plus 2 sine a cos a. You can check that for yourself. Okay. Now I'm happy because I've got 2 similar terms in the numerator and denominator. I've got cos a plus sine a. I've got cos a plus sine a. They cancel, and I end up with cos a minus sine a all over cos a plus sine a if I just flip those 2 terms around. Okay, and we're very happy with that because, once again, it is what they asked us to prove. We have shown that that is exactly the same as the right-hand side. Okay, everyone happy? I'm happy. AB, are you happy?
I'm happy.
Great. So should we take a break or should we carry on?
Let's take a break and then we'll deal with the questions from the mind teachers after the break.
Okay, perfect. Good plan.
Cool, guys. We'll see you after this break. Keep your questions coming if you have some questions. And let's also help one another on the page. If you see someone struggling, let's be a team and help one another. See you after this. Welcome back, Mindsetters. Now, in short, yesterday we have launched an awesome competition, the South Point Accommodation Competition, where you, as a matriculant, stand a chance of winning 1 year's free accommodation at any South Point next to a university that you'd like to study at. So, guys, make sure that you enter right now, and you could be the winner. So, if you're in matric and intending on studying at any tertiary institution next year, better apply right now. More information is on our Facebook page. Well, for now, Natasha, I've got this question for you. It's from Johnny James Bond. Hi, I have one question on trigonometry. Teacher, what I know is Sine theta minus alpha is the same as sine theta cos alpha minus cos theta sine alpha. But now I have a scenario where I have 65 sine theta minus alpha.
All right. Okay, great. So Johnny James Bond. Wow, what a
Yes.
name. Okay. So you know the basic expansion for your compound sine theta minus alpha, and you've got a 65 outside in front of the sine. All you're going to do is use a bracket. So keep the 65 by itself, use your expansion for sine theta minus alpha, and then you times the 65 into the bracket. So that 65 needs to get distributed to every term. Okay, so it mustn't just be applied to the first term. You need to use a bracket and then apply it to all the terms in that bracket. All right, great, AB. So that's
Cool.
it, hey?
Yes.
Okay, great. Guys, we're going to quickly carry on with our questions because I want to try and fit our challenge question in as well. And this is question 3, determine the general solution. General solution you would have done in grade 11. And the way some of you have learned to do it is you use a reference angle and then you put the angle in the right quadrant, determining dependent on your signs, etc. I'm going to show you a slightly different way to do general solutions if you've been using your cast diagrams to put it in the right quadrants, etc. Okay, this is what I mean. Let's get into the question. We've got sine 2x plus cos x is equal to 0, and we have to determine the general solution. So I'm going to rewrite sine 2x as 2 sine x cos x. That's the double angle expansion, okay, of sine 2x. And I've got plus cos x is equal to 0. Now, like any equation that you've learned, remember with your quadratics and that, you want to be able to apply the zero factor law, which you learned in grade 10. You want to be able to have a bracket times a bracket equal to 0. So I'm going to take out cos x as a common factor, right? And I get 2 sine x plus 1 is equal to 0. Now remember, from quadratic equations, you would now apply, without thinking about it, and some of you haven't heard it before, but you would apply the zero factor law, which means if you've got a term times another term equal to 0, you've got to let each one equal 0 in order to solve the equation. Okay, so you let each factor equal 0 in order to solve your equation. You want to see what will make this factor 0 and what would make that factor 0. So that's basically what we're going to do, the same as quadratics. So we've got cos x is equal to 0, okay, or 2 sine x plus 1 is equal to 0. Okay. Now we're going to solve each one individually. And this is where some of you will use the method where you've been told, okay, you can't put a negative into the calculator, so what you must do is you'll then find a reference angle and you will see on your cos diagram where is cos positive, and then you'll do that kind of thing and say, okay, I know it's the first and the fourth quadrant. If you understand and know that method, then you won't be saying, what is she talking about? Because you know what I'm talking about. Then use that method. I'm going to show you an alternate method that many of you already know as well and you already apply, where for cos of an angle equal to a ratio, your general solution is, okay, so this is an aside. So say I've got cos of theta is equal to m. When I'm finding a general solution for cos of theta, my answer is theta is equal to plus or minus, and I'm going to use your calculator function, your calculator button, which is shift. Okay, if I say shift cos, we know I'm looking for an angle, and you see what happens? You get cos to the -1. So that's what I'm doing. Okay, so I'm going to say theta would be equal to plus or minus cos theta inverse of m. Okay, that's your calculator step, plus k times 360. Okay, so that's the way you would solve cos equal to some ratio. K is an element of integers, because remember you substitute values in for k. So cos of theta is equal to some ratio. Theta can then be found by saying plus or minus your reference angle plus k times 360. Okay, And here you're allowed to put m, even if it's negative, you can put it straight into your calculator. All right. Then for sine of theta equal to, say, n, okay, to find my general solution, I say theta is equal to sine, and this is your, again, your calculator step. So I'm going on my calculator. If I was looking for the angle, I'd go shift sine of whatever the angle was. Okay, 2 wouldn't work, but say 0.2, and then we'd get an answer. Okay, so that's what that sine inverse means. I'm looking for the answer for the angle theta. Okay, so that's what I'm writing there. So theta is sine, shift sine of n plus k times 360. Again, k is an element of integers. All right, or theta is 180 minus that plus k times 360. And a lot of you have been shown to find your general solutions in this way, which I'm glad about because it is a much quicker way. And then if we look at tan of theta equaling, let's say, r, okay, then your general solution here for tan would be theta is equal to plus, well, it doesn't really matter if it's a plus, but it's just one answer. Tan inverse r plus k times 180, because remember 180 is the period of your tan graph, where k again is an element of integers. Okay, so for tan you only have one solution, where theta is just your angle plus k times 180, and again you can put in the value of r including its negative. Okay, so that's the method that I'm using. Okay, if you have a different method to solve general solutions, please feel free to use it. This is a correct method, it's a quicker method, and I'm going to show you with what we're doing here now. So I've got cos of x is equal to 0. I'm going to simply, well, solve that just a little bit further down the page. So we've got cos of x is equal to 0. So from what I've just said to you, therefore my general solution is going to be x is equal to plus or minus what angle gives me 0. I go shift cos 0, and I get 90. So therefore my general solution is x is equal to plus or minus 90 plus k times 360, and you'll say k is an element of integers. Okay, done, easy. Then we've got the other part, 2 sine x plus 1 is equal to 0. We first had to get the sine x by itself, so we take the 1 over to the right-hand side, and we divide by 2. So I get sine x is equal to negative a half, right? Because I took the 1 over divided by 2. So from what I've just shown you, my general solution is going to be x is equal to, on your calculator you go, shift sine, and I put the negative in, negative 0.5, and I get negative 30. So my answer is going to be x is negative 30 plus k times 360. And again, you'll write your k as an element of integers. Or for sine, remember it's your reference angle plus k times 360, or it's 180 minus that, so 180 minus 30 plus k times 360. And here you get 210 plus k times 360 degrees. All right, and we'll have there k is an element of integers. Okay, and it makes more sense, as you see, when you're working with numbers, with real numbers, that method makes a lot of sense, and it's very, very quick. So this would be your general solutions to this question. I'm ready for the challenge question. Are you guys ready? Abi, are you ready?
We're ready, but time seems to be against us.
So what do we do?
I suggest that we post the answer for the Mindsetters on Facebook.
Absolutely, guys. So we have unfortunately run out of time. So I will give AB the answer, and it will be up there for all of you.
Of course. Thank you so much, Natasha, and thank you guys for watching this show. And a big thank you to our sponsor, which is MTN SA Foundation, for making sure that we have this show, guys, and all the shows on the Easter School Revision, and also from the Department of Basic Education for their support. We thank them. Thank you, guys. We'll see you some other time. Peace.